Hello students, welcome to this lecture one coordinate geometry. In today's lecture we will discuss exercise 7.2. Okay, so let's get started. So in first question here we have to find the coordinates of the point which divides the join of minus 1 comma 7 and 4 comma minus 3 in the ratio 2:3. Okay, so basically you have to find the coordinates of the point which divides the join of these 2 points in the ratio 2:3. Okay, so we know the formula of section formula. Okay, so we know section formula. So if we use section formula, then we can easily find the coordinates of the point which divides this joining of these 2 points in the ratio 2:3. Okay, so here first we let p of x comma y be the required point. Okay, and now using the section formula, then we obtain the value of x is basically equal to 2 into 4 plus 3 into minus 1 divided by 2 plus 3. Okay, and if we calculate it, then you will get this is equal to 8 minus 3 divided by 5, and this is equal to 5 by 5, and this is equal to 1. And now the value of y, this is equal to 2 into minus 3 plus 3 into 7 divided by 2 plus 3, and this is equal to minus 6 plus 21 by 5, this is equal to 15 by 5, that is equal to 3. Okay, so here basically we use the section formula. So we know if a point p of x comma y divides the join for 2 points a and b, a x1 comma y1 and b x2 comma y2 in the ratio m1 is to m2, then by section formula we get the coordinates of x comma y, that is equal to m1 x2 plus m1 x2 plus m2 x1 divided by m1 plus m2, comma m1 y2 plus m2 y1 divided by m1 plus m2. Okay, so by using that formula we could able to find the value of x, that is equal to 1, and the value of y, this is equal to 3. Okay, so therefore the required point is 1 comma 3. Okay, so therefore here 1 comma 3, this point divides the join of point a, that is 4 comma minus 1, and b, that is minus 3 comma 7 in the ratio of 2:3. Okay, so I think you understand this. So now let us move to question number 2. So in question number 2, it said to us find the coordinates of the points of trisections of the line segment joining 4 comma minus 1 and minus 2 comma minus 3. Okay, so let us see how to solve this question. Okay, so here first we let p x1 comma y1 and q x2 comma y2 are the points of trisection of the line segment joining the given points. That is here, if you see this figure here, we let here the coordinates of p that are x1 comma y1, and the coordinates of q are x2 comma y2. Okay, and here you can see AP, this is equal to PQ, and this is equal to QB. Okay, so therefore the point P divides AB line segment internally in the ratio of 1:2. So here the point P divides AB internally in the ratio of 1:2. Okay, so now x1 is equal to 1 into minus 2 plus 2 into 4 divided by 1 plus 2. Okay, and if you simplify it, then you will get this is equal to 2. Okay, so x1 is equal to 2, and y1, this is equal to 1 into minus 3 plus 2 into minus 1 divided by 1 plus 2. Okay, and if we calculate it, then we will get this is equal to minus 5 by 3. So y1, this is equal to minus 5 by 3. So therefore the coordinates of P are 2 comma minus 5 by 3. Okay, so P of x1 comma y1, this is equal to 2 comma minus 5 by 3. So here point Q divides AB internally in the ratio of 2:1. So this point Q divides AB internally in the ratio of 2:1. So now the value of x2, this is equal to 2 into minus 2 plus 1 into 4 divided by 2 plus 1. Okay, and if we calculate it by simplifying, then we will get x2 is equal to 0. And y2, this is equal to 2 into minus 3 plus 1 into minus 1 divided by 2 plus 1. Okay, and if we simplify it, then we will get this is equal to minus 7 by 3. Okay, so the point Q of x2 comma y2, this is equal to 0 comma minus 7 by 3. Okay, so the coordinates of Q are 0 comma minus 7 by 3. So here we move to question number 3. So in question number 3, here we have given this situation. So here to conduct the sports day activities in your rectangular shaped school ground ABCD. Okay, so here you can see this figure. So here this ground is rectangular shaped ground. Okay, so lines have been drawn with chalk powder at a distance of 1 meter each. Okay, so we have drawn the lines with chalk powder at the distance of 1 meter each, and 100 flower pots have been placed at a distance of 1 meter from each other along AD. So along this line AD, here we have been placed flower pots at a distance of 1 meter from each other. Okay, so as shown in figure, Niharika runs one fourth the distance AD on the second line and post a green flag. So here Niharika runs 1/4 of the distance of AD. Okay, on the second line, here this line, in this line, and post a green flag. And Preet runs 1/5 the distance AD. So here suppose this is Preet. Okay, so Preet runs 1/5 of the distance AD on the 8th line and post a red flag. What is the distance between both the flags? So here we have to find the distance between both the flag. Here we have a green flag and here we have a red flag. Okay, so now we need to find the distance from these two flags. Okay, from these two flags. So how can we find distance between both the flags? Basically here we can use the distance formula. Okay, so if we use distance formula, then we can find the distance between both the flags. And now if Rasmi has to post a blue flag exactly halfway between the line segment joining the two flags, and where should she post her flag? So now it asks to us, where should Rasmi post her flag? Okay, so let us solve this problem. So here it can be observed that Niharika posted the green flag at 1/4 of the distance AD, and here the distance AD is 100 meter. So Niharika posted the green flag at the distance that is 1/4 into 100 meter, that is equal to 25 meter from the starting point of the second line. Okay, so therefore the coordinates of the point G. So here G means the situation, the location of the green flag. Okay, so here the coordinates of the point G is 2,25. And similarly, Preet posted red flag at 1/5 of the distance AD. That is 1/5 into 100, that is equal to 20 meter from the starting point of 8th line. Okay, so therefore the coordinates of this point are, that is the coordinates of the red flag are 8,20. So the coordinates of the red flag are 8, 20. So now distance between these flags by using distance formula. So here the distance GR, this is equal to square root of 8 minus 2 whole square plus 25 minus 20 whole square. That is equal to square root of 36 plus 25, and this is equal to square root of 61 meter. Okay, so we found the coordinates of green flag, that is actually 8, 25, 2, 20, 2, 2, 25. Okay, and the coordinates of red flag are actually 8, 20. Okay, so then by using section distance formula, we find the distance between these flags. Okay, that is equal to GR is equal to square root of 8 minus 2 whole square plus 25 minus 20 whole square, that is equal to square root of 36 plus 25, and this is equal to square root of 61 meter. Okay, so the point at which Rasmi should post her blue flag is the midpoint of the line joining these points. Okay, so if we let the point be A of x, y, then we can use the midpoint formula. So here the value of x is basically equal to 2 plus 8 by 2, and the value of y is equal to 25 plus 20 by 2. Okay, so here we get the value of x is equal to 10 by 2, that is equal to 5, and the value of y is equal to 45 by 2, that is equal to 22.5. Okay, so hence the coordinates of A, that is x, y, is equal to 5, 22.5. Okay, so therefore Rasmi should post her blue flag at 22.5 meter 1/5 line. So Rasmi should post her blue flag at 22.5 meter 1/5 line. So this is our final answer. Now we can move to another question. So let us move to next question. So in next question, here we have to find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by -1, 6. Okay, so here basically we have to find the ratio in which the line segment joining the points this and this is divided by this. Okay, so here basically we will use the section formula. So by using section formula, we can find the ratio in which the line segment joining these points is divided by this. So let us see how to solve it. So here we let the ratio in which the line segment joining -3, 10 and 6, -8 is divided by the point -1, 6 be k is to 1. Okay, so here we let the ratio be k is to 1, and now therefore here by using section formula for in the ratio of k is to 1, here therefore -1, this is equal to 6k minus 3 divided by k plus 1, and if we simplify it, then it implies -k minus 1, this is equal to 6k minus 3, and this it implies 7k is equal to 2, and it implies k is equal to 2 by 7. Okay, so therefore the required ratio is basically 2 is to 7. So the required ratio is 2 is to 7. So now let us move to next question. So in next question, here we also have to find the ratio in which the line segment joining A 1, -5 and B -4, 5 is divided by the x-axis. Okay, so also find the coordinates of the point of division. So here we have to find the ratio in which this line segment joining these 2 points is divided by the x-axis, and we know the any point when the x-axis are of the form x, 0. That means the ordinate is 0, 1, x-axis. Okay, so here we basically will use this concept and we'll find the ratio in which this line segment joining these 2 points is divided by the x-axis, and then we also find the coordinates of the point of division. Okay, so let us solve this problem. So here first we let the ratio in which the line segment joining A 1 comma minus 5 and b minus 4 comma 5 is divided by x-axis b, k is to 1. Okay, so we laid the ratio k is to 1. So therefore the coordinates of the point of division is basically equal to minus 4k plus 1 divided by k plus 1 comma 5k minus 5 divided by k plus 1. Okay, and we know the y coordinate of any point on x-axis is 0. Okay, so therefore 5k minus 5 by k plus 1, this is equal to 0, and if we solve this equation then we will get the value of k, that is equal to 1. Okay, so the k is equal to 1. So here therefore x-axis divides it in the ratio 1:1. Okay, so here x-axis divides this line joining of these points it into the ratio 1:1. Now we have to find the division point. Okay, so the division point, that is equal to minus 4 into 1 plus 1 divided by 1 plus 1 comma 5 into 1 minus 5 by 1 plus 1. Okay, and this is equal to minus 4 plus 1 divided by 2 comma 5 minus 5 divided by 2, and this is equal to minus 3 by 2 comma 0. So the division point are minus 3 by 2 comma 0. Okay, so now let us move to next question. So in next question, here we have given these points. Okay, and these points are the vertices of the parallelogram taken in order, and here we need to find the value of x and y. Okay, so here we basically use the condition for a parallelogram. Okay, so here these 4 points are the vertices of a parallelogram. So let us solve this problem. Okay, so here we let 1 comma 2, 4 comma y, x comma 6 and 3 comma 5 are the coordinates of a, b, c and d. Okay, so you can see this figure. So here the coordinates of a is 1 comma 2, the coordinates of b are 4 comma y, and the coordinates of c are x comma 6, and the coordinate of d are 3 comma 5. Okay, so these coordinates are vertices of a parallelogram ABCD. Okay, so intersection point O, this point O is basically of the intersection point of diagonal AC and BD. Okay, so this point is basically intersection point of diagonal AC and BD, and also divides these diagonals. Okay, so this point divides the diagonals. Therefore, this point O is the midpoint of AC and BD. Okay, so O is basically the midpoint of the line segment AC and BD, and now we can use midpoint formula. So if O is the midpoint of AC, then the coordinates of O are 1 plus x by 2 comma 2 plus 6 by 2. That implies x plus 1 by 2 comma 4. And if O is the midpoint of BD, then the coordinates of O are 4 plus 3 by 2 comma 5 plus y by 2. That implies 7 by 2 comma 5 plus y by 2. Okay, so now since both the coordinates are the same point O, okay, so now we can equate them. So we get x plus 1 by 2 is equal to 7 by 2, and 4 is equal to 5 plus y by 2. Okay, and now if we simplify these two equations, then we will get the value of x and y. Okay, so we get this equation, x plus 1 is equal to 7 and 5 plus y is equal to 8, and it implies x is equal to 6 and y is equal to 3. Okay, so the value of x is equal to 6 and y is equal to 3. So therefore the value of x is equal to 6 and y is equal to 3. So I hope you understand this problem. So now we can move to another problem. Okay, so let us move to another question. So this question is question number 7. So here we need to find the coordinates of a point A, where AB is the diameter of a circle whose center is 2 comma minus 3 and B is 1 comma 4. Okay, so we have to find the coordinates of point A. So let us solve this problem. So here let the coordinates of point A be x comma y. Okay, so now midpoint of AB is 2 comma minus 3. So which is actually center of the circle. Okay, so center of the circle of a diameter, if AB is a diameter of the circle, then here this point 2 comma minus 3 is basically midpoint of the diameter AB. Okay, so now we can use the formula for midpoint formula. Okay, so now here therefore we get 2 comma minus 3, this is equal to x plus 1 by 2 comma y plus 4 by 2. Okay, and it implies x plus 1 by 2 is equal to 2 and y plus 4 by 2 is equal to minus 3. Okay, now if we simplify this, then we will get the value of x and y. So here x is equal to 3 and y is equal to minus 10. Okay, so therefore the coordinates of A are 3 comma minus 10. Okay, so this is our final answer. So now let us move to next question. So this is our question number 8. So here it said to us, if A and B are minus 2 comma minus 2 and 2 comma minus 4 respectively. Okay, so find the coordinates of P such that AP is equal to 3 by 7 times AB and P lies on the line segment AB. Okay, so we have given the coordinates of A and B are minus 2 comma minus 2 and 2 comma minus 4. And here we need to find the coordinates of P such that we have given this condition AP is equal to 3 by 7 times AB. And here we also given P basically lies on the line segment AB. Okay, so let us see how to solve it. So here the coordinates of A and B are minus 2 comma minus 2 and 2 comma minus 4 respectively. Okay, and we have given this condition AP this is equal to 3 by 7 AB. And if you see this figure, then here this point P basically divides the line segment AB in the ratio 3:4. Okay, so here therefore AP is to PB, this is equal to 3:4. Okay, so now point P divides the line segment AB in the ratio 3:4. So now the coordinates of P basically is equal to 3 into 2 plus 4 into minus 2 divided by 3 plus 4 comma 3 into minus 4 plus 4 into minus 2 divided by 3 plus 4. Okay, and now if we simplify it, then you will get this is equal to 6 minus 8 by 7 comma minus 12 comma minus 8 divided by 7. That is equal to basically minus 2 by 7 comma minus 20 by 7. So therefore the coordinates of P are minus 2 by 7 comma minus 20 by 7. Okay, so now here we'll move to question number 9. So here we have to find the coordinates of the points which divide the line segment joining A minus 2 comma 2 and B 2 comma 8 into the 4 equal parts. Okay, so now let us see how to solve it. So here from the figure, here you can see this figure. So from this figure here it can be observed that the points P, Q and R are dividing the line segment in the ratio 1:3 and 1:1 and 3:1. Okay, so P divides the line segment in a ratio 1:3. Q divides the line segment in the ratio 1:1 and R divides the line segment in a ratio 3:1. Okay, so now the coordinates of P are 1 into 2 plus 3 into minus 2 divided by 1 plus 3 comma 1 into 8 plus 3 into 2 divided by 1 plus 3. Okay, and this is equal to minus 1 comma 7 by 2. So therefore the coordinates of P are minus 1 comma 7 by 2. And now for next one, here the coordinates of Q. So coordinates of Q, here basically Q divides the line segment in the ratio 1:1. Okay, so now the coordinates of Q is equal to 2 plus minus 2 divided by 2 comma 2 plus 8 by 2. And this is equal to 0 comma 5. And now the coordinates of R. For finding the coordinates of R, here we will use the section formula. Here basically the point R divides the line segment in the ratio 3:1. Okay, so the coordinates of R is equal to 3 into 2 plus 1 into minus 2 divided by 3 plus 1 comma 3 into 8 plus 1 into 2 divided by 3 plus 2. 3 plus 1. Okay, and this is equal to 1 comma 13 by 2. So therefore the coordinates of Q are 0 comma 5 and the coordinates of R are 1 comma 13 by 2. Okay. Next question. So here in next question, here we have to find the area of a rhombus if the vertices are given to us 3 comma 0, 4 comma 5, minus 1 comma 4 and minus 2 comma minus 1. Okay, taken in order. So here we have given this hint. So here what is this hint? So here we know the area of a rhombus, that is actually equal to half into product of its diagonals. Okay, so area of rhombus, this is equal to half into product of its diagonals. So here we let 3 comma 0, 4 comma 5, minus 1 comma 4 and minus 2 comma minus 1 are the vertices of A, B, C and D of a rhombus ABCD. Okay, so now length of AC, this is equal to square root of 3 minus 1 plus 4 minus 0 whole square, that is equal to square root of 16 plus 16, that is equal to square root of 32, that is equal to 3 into square root of 4 into square root of 2. Okay, so the length of AC is equal to 4 into root 2. And now we will find the length of BD. So here length of BD, that is equal to square root of 4 minus 2 whole square plus 5 minus 1 whole square, that is equal to square root of 36 plus 36, that is equal to 6 times root 2. Okay, so therefore the area of a rhombus ABC, this is equal to half into 4 into 2 square root of 2 plus area of a rhombus ABC is equal to half into 4 into root 2 into 6 into root 2, that is equal to 24 square units. Okay, so therefore the area of a rhombus ABCD is equal to 24 square units. And now I stop here this lecture. Thank you very much to all of you.